Hey, what's up, Logic fans? It's Ash again, coming at you with the final section of Chapter 4. So, Quantificational Symbolization 13, the meaning of identity. We covered the mechanics of the identity symbol in the previous section, 412. We're presupposing that now, and we're going to talk about what some of those statements and sentences that you actually formed in 412 mean. Let's rock. Okay, so as you know from 412, each of these is in fact a quantificational sentence, okay? And if we let P stand for Peter Parker and S stand for Spider-Man, what would this sentence mean in ordinary English, and likewise for all of them? Pause now. Okay, so hopefully you've paused and worked through this, but this is going to be Peter Parker is identical with Peter Parker, okay? Pretty simple. This one is Spider-Man is identical with Spider-Man. Pretty simple stuff, right? So this one says that Peter Parker is identical with Spider-Man. Happens to be true, but even if it was false, that's the statement, okay? This one is Spider-Man is identical with Peter Parker. Okay, so notice the order of the the relata. Okay, so the S is here, so the S appears here. Okay, okay. Let's try a slightly different one. How about this one? Try this one. What does that mean in ordinary English? So this says Spider-Man is not identical with Peter Parker. Okay. Or it is not the case that Spider-Man is identical with Peter Parker. So remember, we could translate this way if we wanted, right? In which case, that makes it a little bit more clear, where we would be saying something like, it is not the case that Spider-Man is identical with Peter Parker. Okay? Either one of those would be absolutely fine there. Okay, let's slowly start ramping up in complexity and look at some other types of identity statements, or statements that involve the identity symbol. For example, some of these. What do these sentences mean in ordinary English? Pause now. Okay, so let's go through these together. This means there's at least one thing in my domain that is identical with Peter Parker. So you could say something is identical with Peter Parker. All right. Another way of saying the same thing would simply be to say Peter Parker exists. Okay. That would be a perfectly adequate translation as well. All right. What about this one? This one says something is, now check this out. Something is such that it is identical with Peter Parker, right? Or pardon me, rather, since it occurs here, something is such that Spider-Man is identical with it. So I'll actually write that out. Something is such that Spider-Man is identical with it. Once again, it's like saying Spider-Man exists, okay? But that would be the technically accurate translation. So there's at least one thing in my bag, one thing in my domain that satisfies this description. Spider-Man is identical with it, okay? That's the idea there. So I'll just say colloquially, Spider-Man exists. Okay. Let's go ahead and try this one. Everything is identical with Spider-Man. Okay. So I'll write that down. But okay, this is also subtle, and this is something we're going to be talking about today. Everything is identical with Spider-Man is kind of like saying only Spider-Man exists. The only thing that exists is Spider-Man. Right? So suppose you're thinking like, oh, what if I have a domain with like 5 things in it? Well, if this statement is true, then those 5 things are all identical. They're all identical to Spider-Man. So only Spider-Man exists. Okay? That's what it's like saying. So everything is identical with Spider-Man. Everything in my domain satisfies this description. It's identical with Spider-Man. Everything in there. Okay? This one says, again, this one's a little bit backwards, but, everything is such that Peter Parker is identical with it. So reach into your bag. Whatever you pick out, it's guaranteed to satisfy this description. Peter Parker is identical with it. So once again, this is like saying only Peter Parker exists. Okay? This one's interesting. All right, let's go ahead and try this. This says everything in my domain satisfies this description. So everything is not identical with Spider-Man. Another way of saying that would be like saying nothing is identical with Spider-Man. So nothing is identical with Spider-Man. Let's put that up here. Right? Everything in my domain satisfies this description. It's not identical with Spider-Man. So it's like saying Spider-Man does not exist in my bag. Right? Interesting stuff. Okay, so you're starting to see that now that we've introduced the identity symbol, okay, we can form these constructions, and as you are starting to get the idea of our expressive power is increasing dramatically now that we have the ability to assert or deny identity. Okay, let's take a look at this one. Nothing is identical with Spider-Man. Okay. So it's not the case that something is identical with Spider-Man. Nothing is identical with Spider-Man. Okay, Spider-Man does not exist would be another way of thinking about it. Right? There's nothing in my bag that satisfies this description. So Spider-Man does not exist. Okay? Pretty interesting, right? Okay, so for these ones, let's take Peter Parker and Spider-Man out of it altogether and work not with any kind of individual constant, but just exclusively with individual variables. So this was a sentence, as we saw in the previous section, 412, but the question is what does it mean? Go ahead and try to translate that for yourself now. So this says at least one thing is identical with itself. So I'll translate it loosely. Something is identical with itself. Now, of course, intuitively, we know that everything is identical with itself, which is what B says here. And that's something B that we're going to accept as axiomatic in chapter 6. But another way of thinking about this is it's our way in logic of saying something exists. Okay, it's our way of saying something exists. It's kind of cool, right? Because since everything is identical with itself, if at least one thing satisfies this description, in other words, if this sentence is true, it's got to be that your domain is non-empty. Something exists, right? So contrastively, if we said it's not the case that at least one thing exists, it's not the case that something exists, that would be like saying nothing exists. Okay, so we actually have a way of expressing these ideas, okay? And expressing it as nothing exists, sometimes it confuses students. It is a little bit colloquial to express it this way. Students get confused and say nothing exists. Well, is that like a thing that's actually existing or something? No, that's not the idea. It would be better to render it, in its total logical form so that doesn't confuse you, as saying it is not the case that something exists. So provided that's true, it's like saying nothing exists, right? But when you stretch it out this way, it is not the case that something exists. You're less apt to get engaged in those kinds of metaphysical wormholes, which you should absolutely take a metaphysics class in, where those kinds of things get discussed. How are we supposed to understand existence, okay? All right, let's go ahead and revert this back to something exists. And let's try B. Pause now and try B. Okay, B says that everything is identical with itself. Notice that's true even on the empty domain, so that's interesting. Whoops. So the idea here is that pick anything you like out of your bag. Suppose you got a bag, it's got 10,003 things in it. Pick any one of those 10,003 things in it. That one you picked out, no matter which one it was, it satisfies this description. It's identical with itself. And that's absolutely true. Okay, that's absolutely true. All right, try C. All right, this says everything is identical with everything. So hopefully our study and detailed treatment of relations is helping you with these translations, okay? Everything is identical with everything. So let me give you an example. Suppose I have a domain and it's only got one object in it. Is this sentence true or false? Well, it'd be true, right? Of course it'd be true, because everything is identical with everything. Now, suppose I have a domain, it's got two objects in it, A and B. Is this same sentence, C here, is it true or is it false? Is it true that everything is identical with everything? No, it's not, right? Because it's true that A is identical with A. It's also true that B is identical with B. But it's not true that everything is identical with everything, which would mean that A is identical with B as well. Okay, and so if I've got two things in there, then this is not true of that domain. But what it means is that everything is identical with everything. So it's only true provided one thing exists. It is true on the empty domain as well, but that's about it. Okay, go ahead and try D. What does D mean translated? It says something is identical with something. Now, on the empty domain, this is absolutely false, okay? But on any other domain, it's true, because if you have at least one thing that exists, that thing is going to be identical with itself, thereby ensuring that something is identical with something, in this case itself, okay? Which is interesting. So let's go ahead and try E here. E would be translated, right, something is such that something is identical with it, which once again is going to be true on any domain containing at least one object, any non-empty domain, okay? So it's basically the same as D, except it's just stated a little bit more elliptically from the point of view of this relata, right, rather than the point of view of this one. Okay. F, everything is identical with something. Once again, provided you have at least one object in your domain, that's going to be true. And of course, also since it's a universally quantified statement, it's true on the empty domain. But everything is identical with something, namely itself, right? So kind of interesting, all right? But that's what it means, okay? G, something is identical with everything. This is an interesting statement, so let's take a second to understand this one. Something is identical with everything. Okay, so it's an existentially quantified statement, therefore it's going to be false on the empty domain. It requires at least one thing to exist, but something is identical with everything. That would require that there's at least and at most one thing, okay? So there's got to be at least one thing in order for this to be true, and there can only be at most one thing, because whatever's making this statement true, that object is identical with everything. So A is identical with B, A is identical with C, A is identical with D, right? Everything is A. It's kind of like, think of it that way. Okay, let's try some more things here. So this is kind of interesting and fun. Translate this sentence for me. So here's a sentence for you. Let's do this one. So how would you translate this sentence? There are no unicorns, where UX means X is a unicorn. It's a property constant for being a unicorn. So how would you translate that? Pause now. Okay, so the way we would say this, right, is it's not the case that there exists an X, all right, such that what? Such that X is a unicorn, right? This says, let's picture it this way. This says at least one unicorn exists, i.e. there are unicorns, at least one, okay? So the denial of that says there are no unicorns. There's no such thing as a unicorn, right? This said nothing exists, and this says nothing exists because everything is identical with itself. So if this is true with the negation here, given that everything is identical with itself, it could only be true provided it was an empty domain, provided nothing exists, nothing whatsoever. This is a weaker claim. This doesn't say nothing exists. It just says there are no unicorns. No unicorns exist. Okay? So that's exactly how you would translate a sentence like that. Okay, let's spill on to the next video so we're not rushed. So look for 4.13b. See you there.